Okay, let's look at this problem together. Okay, so this is an exercise, okay, for you guys to get to know this problem before we discuss it. So the number of emails a professor receives from students each hour on the day before the exam is a Poisson random variable. Okay? Recall that Poisson random variable y is the number of events occur in some interval, and it has the following probability mass function. So you have this probability mass function is lambda k over k factorial exponential minus lambda. Now, if you have an interval, okay, each hour, so this is what is happening, right? This is time, and you have event, event, and event, event, and if you limit the event to be within an hour, okay, this is 1 hour period. Okay. So then the probability is that within this interval we are going to have k events. That is probability that is lambda y over y factorial exponential minus lambda, and this y equals to 0, 1, 2, 3. So this is Poisson distribution. This is what we just discussed, number of events in a given interval. Now, we are not interested at the number of events in the given interval. That is, if you are counting the number of events in a given interval, that is a discrete random variable, right? Now we are interested at the interval between events, time interval between events. So what is that? That is this interval, okay, and or this time and or this time, okay. So what is the distribution of the time between events, between successive events? Now, time between successive events, that is a continuous number, okay, and it's random. So now it will become a continuous random variable. Now, we are assuming that the emails arrive at the rate lambda equals to 0.1. This is 0.1 minutes emails per minute. So what's the probability that the time between successive events, emails, is at most 40 minutes? So what is this? Now, let y to be number of emails. Now, because we are interested at 40 minutes, right? Per 40 minutes. Now, this y obviously is the number of emails, so it should be Poisson. Now, but Poisson, what will be the lambda? This lambda 1. So this is lambda equals to 0.1. So what is this lambda 1? But this is 40 minutes. This is per minute. So lambda 1, because lambda equals to 0.1 emails per minute. So lambda 1 will equals to 0.1 times 40 equals to 4 emails per 40 minutes. This is what we just discussed, changing time intervals. Okay, so lambda 1 should be 4 emails per 40 minutes. Now let's define another new random variable. This random variable will be time between events. Okay? So our question is probability time between successive emails is at most 40 minutes. Is that what we want? This is a probability that the time between successive emails is at most 40 minutes. Can you see it? Do I need to turn off the light? Huh? Siqi, is it okay? Yeah. Okay. Seems that it's a little bit blurry when I look at the monitor. So this will equals to, this is actually x less than or equals to 40. Agree? At most 40. Time between successive event is at most 40. So what does this equals to? This equals to 1 minus probability x greater than 40, right? So what is x greater than 40? X greater than 40 is 1 minus probability no emails in 40 minutes. Agree? Because at most 40, right? At most 40, that's less than. Now it's greater than. Time between events is more than 40. That means within 40 minutes there will be no emails in 40 minutes. So this will equals to 1 minus probability y equals to 0. So equals to 1 minus lambda 1 y divided by y factorial exponential minus lambda 1. But we know y equals to 0, so this equals to 1 minus exponential minus lambda 1. And this equals to 1 minus exponential minus lambda. What is lambda 1? 4, agree? Now, the second question is, yeah?
So, what about the y equals 1? So, if there is an event happened, and then 40 minutes, there is a gap, then another event happens. So, like, the probability of x is less than or equal 40, isn't it equal, like, the probability that y is more than or equal to within 40 minutes?
Can you say it again?
So, probability of x is less than or equal 40. And what I was
So
thinking
time
is
between successive emails is at most 40, right?
Yeah. So there is an event happened, and then 40 minutes, and then another event happened.
So this is less than or equals to 40, and which equals to x greater than 40. So that means no emails within 40 minutes because your x time between successive emails is greater than 40. Okay? But if you have to study the boundary, because this is continuous, okay? And if you have to say, oh, 40, exactly, there's a 40 point goes to infinity small, then I think in general I'm trying to connect the Poisson random variable with exponential random variable. What I'm trying to tell you is the number of events, okay, in a given interval is a discrete random variable. So the discrete random variable is actually Poisson. And for Poisson distribution, the time between events is exponential. Okay? And the bridge between this distribution is actually this thinking. It's at most is 40. Then you go to the complement. And because it's less than, right? For x, it's less than. If you x less than t, this is CDF. Agree? So if you take the CDF and then take the derivative, you will get the PDF for exponential distribution. But the connection between Poisson and exponential is right here. This is what I want you guys to retrieve your memory from previous discussions or previous exponential distribution or Poisson distribution. Okay, but that's a very good point. Now the second one is actually what we're trying to generalize this. So given a Poisson random variable with rate lambda, okay, per unit interval, okay. So now we are saying we have a Poisson per random variable y, and that is rate parameter is lambda per unit interval. What is the probability of the interval between successive events random variable x is less than or equals to x? So now if y equals to number of emails still per x minutes. Okay. This is smaller x. Okay. Or we can use t, but let's use x. And then y will equals to is approximately Poisson distributed with lambda 2. But what is lambda 2? Lambda 2 equals to lambda times x, right? Because that is per unit interval. Now you have per x, okay? Now if we have x is time between events, so fx is actually equals to this is smaller x, and equals to probability capital X less than or equals to smaller x. So this will equals to 1 minus probability x greater than x. This equals to 1 minus probability y equals to 0. So this is 1 minus exponential minus lambda x. Okay. Now we got the CDF function. This is our CDF function. Now what is a PDF function corresponding to the CDF we derived? So fx is actually f prime x. So if we take the prime, this will equals to lambda exponential minus lambda x. So this is comes to the exponential distribution. Okay. So this is how we connect Poisson and the exponential. Poisson is number of events in a given interval. So you can think about the rate is the average event per unit. So if you consider t, and then that will be lambda t. Now we consider x is lambda x. Okay, x, the interval length. Okay, what if there is now we are interested in the interval between events. So that's how we make connection with the between successive events is at most 40, right? Between successive events. So x is between successive events at most 40. So 1 minus x greater than 40. No emails in 40 minutes. That means 1 minus no emails within 40 minutes. We know the lambda for the 40 minutes. So we can calculate this value. But if we make it general to be x, then we just get the CDF function. And then take the derivatives, we got the PDF function. That means the x, time between events, is exponentially distributed. Okay, so here is the connection between Poisson and the exponential. Now, after we finish the connection, now we are going to get into the exponential distribution. So that's